Welcome to another session. So if you haven't subscribed or you are new to the channel, please subscribe and then like the video, share with your friends, and comment down there on the comment section. This session we're going to be focusing on or be looking at this concept of vertical projectile motion. So one can ask him or herself that what exactly is a vertical projectile motion? So this is the motion of an object that is launched or thrown vertically upward into the air and then falls back down under the influence of gravity. So we can say that the key concept of this vertical projectile motion is that the only force acting on that object is gravity, okay, which causes it to accelerate downward at a constant rate of 9.8 meters per second, which is the gravitational acceleration, assuming that there is no air resistance. So we know that if we throw a ball vertically upward, it will come back down, or it will come back to the reference point, which is your hand. And the only force acting on that object is the gravity. All right. So if we have a ball here, and this is our initial position, this is the motion of the ball. You throw the ball vertically upward, then this is the ball at this stage, and then we know that the ball will reach a height here whereby it will be able to change direction and then comes back to the reference point. So this is our reference point. So the only force acting on this ball, as soon as it is released or as soon as it is projected upwards, the force that is acting on this ball is our gravitational acceleration, or our gravity. So throughout the motion, the only force acting on this ball, even here or at the maximum, or even here when the ball comes down or accelerates down, the only force acting on this ball is our gravity, our force of gravity, which we know that it's equals to 9.8 meters per second squared. This is our gravitational acceleration. So during this vertical projectile motion, the object's initial velocity determines how high it will rise before starting to fall back down. So as the object rises, its velocity decreases due to the opposing force of gravity. All right, because now we project this ball, okay, we throw this ball at a velocity v. We have a velocity v going in that direction. All right, and the gravity is trying to pull back the ball to the ground. So as the ball goes up, the velocity of this ball decreases. All right, so as the ball goes up, the velocity is no longer the same as the velocity as it was thrown at. It starts to decrease slowly until it reaches the apex, or we can call it the highest point, which is this point here. This is our apex. So when the ball reaches that highest point, its velocity is momentarily zero. So when the ball reaches our apex, our v value, or our velocity v, is now 0 meters per second. Then that allows the gravitational acceleration to pull back the ball down to the ground, because now that is the point where the ball will change direction and then start coming downwards. Right? So after it has reached the apex, the object then begins to fall back, okay, accelerating due to the gravity. So now when the ball comes back, it will accelerate due to the gravitational force. So the motion of the ball in this vertical projectile motion can be described using equations of motion, or we call it the big four equations of motion from the Newton's law or from the laws of physics. We derived those equations from the laws of physics. So the first equation says that V final is equals to V initial plus A changing T. And then we have the second one, which is Vf squared is equals to Vi squared plus 2A changing X. And then we also have changing X is equals to V initial multiplied by changing time plus half acceleration changing time squared. And then we also have the last one, which says changing displacement is equals to V initial plus V final divided by 2 changing T. So Vf is for V final or the final velocity, and then V initial is the the velocity initially, or the velocity at which the ball was projected at, or the velocity at which the ball was thrown at. All right, so the A, it's for the acceleration, and we know that the acceleration which pulls the ball throughout the motion is the gravitational acceleration. So on all of these formulas, where you see A, we have to know that we're talking of the gravitational acceleration. So where we see A, it's the same as gravitational acceleration. All right, then change in X, we know that that is change in displacement, and we know where change in displacement is the final position minus the initial position, or we measure the position from the initial to the final position in a straight line. So now if we want to check the displacement of the ball was projected upward, it reached the maximum height, and then it came back to the initial point. So our initial point was this one, and our final point was this one. So it means that our displacement in this case is equals to 0, because the ball went up and then came down to the same position. So when we talk of the displacement, is the same as the ball did not go anywhere. But when we want to calculate the distance the ball traveled, then we talk of a different story. All right, so we also have another quantity, which is time. It's simple to calculate, and then always we have to choose direction. All right, we have to choose direction. But here on Earth, we know that the gravitational acceleration is always pulling any object down. All right, so if you can take down as positive, if you take the motion going down as positive, then it means any motion going up must be negative. So I think we should check on an example and see how we can apply the big four equations. So we're given a ball of mass 200 grams, which is dropped from the roof of a 100-meter high building. So we must ignore the air resistance and calculate the following here. We must calculate the velocity of the ball when it hits the ground, and we must also calculate how long the ball is in the air before it hits the ground. So if you analyze this question, it means that we are having the ground here, and then we're having a 100-meter high building. All right, so from the tip or from the top of this building, exactly here, we're having a ball of mass 200 grams, and this ball now it's dropped from the top of the building. So the ball goes and goes until it hits the ground somewhere around here. All right, so they want us to calculate the velocity of the ball and everything. So one thing I want us to be aware of, when we drop something, you must know that the initial velocity of that object that is being dropped is 0 meters per second. Why? Because when you drop an object or a particle, you don't necessarily apply a force on your hand to release that object. You just have to open your hand, and then that object will be dropped. So when you see the weight dropped, just know that you see the initial velocity of that certain or particular object that is dropped to be 0 meters per second. And then the first question, they want the velocity of the ball when it hits the ground. So they want the final velocity of this ball, which we are looking for. So from our formulas, we can see that we have quantities such as our V initial, we have our V final, we have the change in time, we also have the change in displacement, and then we also have our acceleration or our gravitational acceleration. So when you do a question, you must first identify or do the information analysis for all the quantities, so that you can be able to choose the correct formula to use here. All right, so before doing any sort of calculation, we must first choose the direction. So in this question, I'm going to take the motion going down, or I'm going to take downward as negative. Right, because I'm using the fact that these are the positive y-axis, these are the negative y-axis, if these are the x-axis, you see. So any motion going down, it's negative in this question. All right, so now because we have chosen the direction, then now we can try to fill our information for these quantities. So we know that our initial velocity is 0 meters per second, right? Then we're looking for the final velocity. Then from the statement, we were not given the time it took the ball in the air, right? And then our change in displacement. Remember, when we find the change in displacement, we just want to find it's like we're finding the distance in a straight line. So from the initial position to the final position in a straight line. So remember, when we calculate the change in displacement, we say final position minus the initial position. So if you can check, the initial position or the final position of this ball will be here on the ground, which is 0 meters, right? So this is 0 meters minus, then the initial ball was 100 meters above from the ground. So we put 100 meters here, and then the difference now it's negative 100 meters. So it means that our displacement is negative 100 meters. And it's true. Why? Because we said that the motion going downwards should be negative. You see, so any motion going downwards, so the ball will have to move from this 100-meter building to the ground, which is going down, and then our down it's negative. All right, so we have our g, or our gravitational acceleration, which we know that it's 9,8 meters per second squared. All right, so we said any motion going downward must be negative. So remember, when the ball is dropped, the only force acting on this ball is our gravitational acceleration, and it's pulling the ball downwards. So it means our gravitational acceleration is also negative. You see, so remember, we are looking for our V final. So it means time in this case, we don't need it. We don't need time in this case. So we can focus on these four quantities that we have now, right? So we have our initial velocity, we're looking for the final, and then we have the displacement and our gravitational acceleration. So you can see this, the first two equations, all right, they have the initial velocity and the final velocity. Then the first one has the acceleration and time, which we don't need time for this question. Then it means the second equation is the one that is going to work for us. All right. So we're going to say Vf squared is equals to V initial squared plus 2 multiplied by our gravitational acceleration, and then changing y. We can put change in y for changing x, because our motion is on the y direction. All right, so our v final is the one that we're looking for. Then we're going to say Vf squared is equals to our initial velocity is 0, then we have 0 squared plus 2 into, then our gravitational acceleration together with its sign, it's negative 9,8, and then our displacement is negative 100 meters. And then now our v final squared is equals to 0 multiplied by this one, and then we're going to get 1960. And then now we can take the square root of both sides, and then we have the square root, which is plus or minus 1960. Then now our v final becomes plus or minus 44.27. all right, so the velocity can either be positive or negative. So remember, the velocity of this ball is going, the ball is going downward. So it means the velocity should also be going downward. So it means our velocity should take the direction here, which is negative. Then it means our Vf, it's equals to negative 44.27 meters per second. All right, so we have to take this negative and then write it in terms of direction. So it means our v final now becomes 44.27 meters per second. All right, and then this negative, now we write it as downward. Then in this case, we have calculated the final velocity of this ball. Now we know that the final velocity of this ball before or when it hits the ground, it will be 44.27 meters per second. All right, or we can put it in direction form to be negative 44. All right, then we have calculated the first one. Then the second one says calculate how long the ball is in the air before it hits the ground. The how long part. How long does it take to do what? So it means they want what? They want the quantity of time. So we want the time that the ball spend on the air before it hits the ground. So for number two, right, we are looking for the change in time. But remember, we have the v initial of this ball, which is 0 meters per second, and then we have our v final, which is negative 44.27 meters per second. And then we also know that the ball traveled for negative 100 meters. And then now our gravitational acceleration, we know that it's negative 9,8 meters per second squared. Then now we are looking for the quantity of time. So this is the information that we have now, right? So from this, we have the v initial, the v final, we have almost everything. So when you go to these formulas, all right, you have our v final, we have our v initial, we have our gravitational acceleration, then we're looking for the time. So we can use the first equation, all right, or even if you can use the third equation or the fourth equation, it's still fine. We'll get the same answer. So the simple one is the first equation. So we're going to say V final is equals to V initial plus our gravitational acceleration multiplied by the changing time. So our V final is negative 44.27, which is equals to 0, which is our initial, and then plus, then our gravitational acceleration is negative 9,8, and then we multiply that by our changing time. Then now our changing time becomes 44,27 divided by 9,8, and then we get that our changing time now it's 4,52 seconds. So it took the ball 4.52 seconds in order for it to hit the ground. So our time that we got here is 4.52 seconds. So it took the ball this time in the air before it can hit the ground. So we are done with this question. I hope it makes sense, even if it doesn't make sense, but let it make sense a little bit. All right, so we can check another one so that we get the gist of this concept and how to apply these big four equations. So we're given a ball which is thrown vertically upward at 4 meters per second, and the ball returns to the thrower's hand. This is the statement that we're given. And then they say, let the direction of motion downwards be positive. So in this case, we are choosing, we are already given the direction. So they say that the motion going downward must be positive. All right, so it will be positive throughout the question, any motion going downward. So we are given a ball which is thrown vertically upward at 4 meters per second, and then it returns to the thrower's hand. So let's say this is the thrower's hand. This line that I'm drawing here, it's not a straight line. Yeah. All right, so this is the thrower's hand. This is the thrower's hand. All right, so the thrower throws the ball vertically upward. So the ball was here, then it leaves this hand at a velocity going upward at 4 meters per second, and then the ball goes upward, and then it will reach a maximum height here, and then the ball will return to the thrower's hand, just like this. All right, so they say to us, they want us to calculate the maximum height reached by the ball. All right, but already we were given the direction that the motion going downward is positive. So it means any motion going upward it's negative. All right, so our quantities in this case, we have our V initial, we have our V final, we have our change in X, we have our change in T, we have our gravitational acceleration. So this ball is thrown vertically upward. So it means the motion of the ball on this side going upward until it reaches the maximum height, it will be negative. Then when the ball comes down, because we said any motion going down, it means it will be positive. You see? So it means the velocity of the ball, if the ball is going up, then the velocity should be negative to take the direction of motion. All right? So the ball was thrown at a velocity of negative 4 meters per second. Then it will go and reach the maximum height and then comes back to the thrower's hand. All right? So they want us to calculate the maximum height reached by the ball. So allow me to do this. So this was point one of our motion of the ball, and then now the ball reached the top or the maximum height or our apex, as we can say. And then now the third position of the ball was when it returned to the thrower's hand. So this was position one. Position two is the maximum height, and then position three is when the ball returned to the maximum or to the thrower's hand. I'm sorry. All right. So to calculate the maximum height of this ball, we have to consider the path from one or from point one to point two, because it was thrown here and then here at point two it reached the maximum height. So we can do our data looking at this path from 1 to point 2. So our v initial, we know that it will be negative 4 meters per second. Then our v final, because we know that when the ball reaches the apex or the maximum height, its velocity is momentarily 0. So here the velocity of the ball at point 2, we know that it's 0 meters per second, not squared but second, -1. All right, so we are looking for the change in x, the displacement of this ball. The maximum height reached by the ball is the one that we are looking for. Then when we talk of change in time, we don't have the time. We don't have the time from the statement, how long it took the ball to reach the maximum height. And then our gravitational acceleration in this case, remember one thing you should remember is that whenever the ball, whether it's going upward, if the ball is going upward, the only force acting on it, it's gravitational acceleration. So the gravitational acceleration will forever pull the ball downward. So it means now our g, it's negative 9,8 meters per second squared, because the gravity will forever pull the ball downwards. So this force is acting downward. So our gravitational acceleration in this case is negative 9,8 meters per second squared. So because our direction, they said that any motion going downward should be positive. All right, we know that the gravitational force pulls any object downward, and then it should be negative. But if you are given that any motion going downward, it's positive, then it means when this force is pulling the object downward, it's pulling it in a positive direction. Why? Because we took downwards as positive. So now our gravitational acceleration becomes positive 9,8. I hope it makes sense, and if I complicated you, I'm sorry, but yeah, this is how it is. All right, so when we calculate this, we have to go and check for the relevant formula. Here we have the v final, the v initial. All right, we are looking for the maximum height. So the time, for now we don't necessarily need the time, so we can check on the two formulas here, because we have v initial and v final. All right, so we don't have time, so it means we can use the second equation. All right, so when we use the second equation, then we are having vf squared, which is equals to v initial squared plus 2 multiplied by our gravitational acceleration change in displacement. All right, so our v final is 0 squared, which is equals to -4 all squared plus 2 into positive 9.8, and then multiply by our displacement, and then now we have 0, which is equals to 16 plus 19.6 multiplied by our change in y. Then our change in y now becomes negative 16 divided by 19.6. Then now our change in displacement is negative 0.82 meters. All right, so we got a negative answer, and which is true. Why? Because the ball is going upward, and I told you that when the ball is going upward, we will have a negative, we have a negative result. So here our ball will be 0.82 meters above from the thrower's hand. So when you change this negative to direction, then we can say therefore our change in y is equals to 0.82 meters above, or we can above the straight line. Above the straight line, or the starting level. All right, so the ball, now we know that our maximum height here, all right, our change in y here is 0.82. all right, but in this case, let's not complicate ourselves, and then write that our change in y, we know that it's negative 0.82, so that we know the direction and the magnitude of this. All right, because if we write 0.82, then you might forget that the motion going upward is negative, and then when you substitute in the next question, you substitute 0.82, and then it can complicate your things there. All right, so the second one says calculate the time taken for the ball to reach the highest point of its trajectory. So they want us to find the time it took the ball to reach the maximum height. All right, so we're still on the path A, B, or the path from 1 to 2. All right, so we can use the same information here. But in this case, we know that our displacement is negative 0.82 meters. All right, and then we're looking for the changing time of this motion. Then to get the changing time for this motion, we can check the formulas here, right? So from these formulas, we can use the first formula, because we have v final and v initial, and then our constant, and we're looking for the time. The second formula won't work because it doesn't have the quantity of time. The third formula can work, and the fourth formula can work, but the most simplest one is the first formula here. All right, so our first formula says, okay, this is number 2. It's saying v final must be equals to v initial plus a multiplied by change in t, and then our v final, we know that it's 0, and then our initial velocity, it's negative 4, plus our gravitational acceleration, then it's positive 9.8 meters per second squared multiplied by change in time. And then now our change in time, then we take this 4 to the other side, and then we divide it by 9.8, and then we're going to have 4 divided by 9.8. Then the time it took for the ball to reach the maximum height, it's 0.41 seconds. So this is the time it took for the ball to reach the maximum height. So the motion of the ball from here to here, it took 0.41 second. Our time is 0.41 second in order for it to reach the maximum height. So the third question says calculate the total time that the ball is in the air. All right. So one thing you should know, or you should always keep in mind when we look at this motion. This ball was thrown from the thrower's hand, then it reached a maximum height, and then it came back to the thrower's hand. So in physics, they say that the time taken for the ball to reach the maximum height is equals to the time it will take to return to the thrower's hand. So it means that if it takes 0.41 second to go to the apex, then it means it will also take another 0.41 seconds to return to the thrower's hand. So when we answer this question, which is number 3, we know that the time it takes for upward motion must be equals to the time it takes to return to the thrower's hand. Because the ball moves from this point and then it comes back to the same point. It goes up, reaches the maximum height, and then comes back down. So if it takes 1 second, then it should take 1 second to come back. So it means the total time the ball is in the air, it will be 1 second for going up and then 1 second for coming down. So now it means you are going to have 2 multiplied by 0.41 seconds, and then we get that it's 0.82 seconds, just like this. Or you can have 0.41 plus 0.41, which is our total time. Then it will give you the same answer, which is 0.82 seconds, just like that. So this is what you should know, that when you throw something, then it reaches the maximum height and then it returns to the same level where it was initially at. Then the time taken for it to go up is the time it will take for it to return to that same level that it was thrown at. So this is simple. So they want you to calculate the ball's total displacement during the motion. All right, they want you to calculate the displacement. So remember, displacement is the measure of distance in a straight line from the initial position to the final position. In this case, from grade 10, we know that if this is your starting point and then this is your final point, this is your initial, this is your final point. When we want the displacement, no matter here we have a mountain or what, the displacement will be measured in a straight line, just like this. And then that is the displacement. But when you calculate the distance of something, we want to know whether this ball went this way, that way, this way, that way, this way, that way, and then until it reaches the maximum or the final point. So the green one is our distance, and then the displacement, we measure it from the initial to the final position in a straight line. So when we look at this motion, the ball has what we call the distance. The ball traveled a distance because it went up and then came down. All right. So our initial position was here. The ball went up, reached the maximum height, and then came down to the same position, which is our final position. So you can see that the ball does not have a displacement. The displacement of this ball is... So to answer number 4, the displacement, the change in x of this ball is 0 meters. Why? Because the ball went, it was initially here and it returned to the same position, okay, which is the final position of the ball. So we can't measure anything on a straight line here, because if initially it was here and the final position was exactly at the initial start, then we don't have the displacement. All right, so the ball has what we call the distance, but the displacement of this ball, it's 0 meters. All right, so I hope it makes sense, and you see how we apply these equations here, even though the two questions were more similar to each other, but yeah, that's how we apply these formulas. There will be questions whereby we will be using almost all these formulas, but for now this is how we work with these big four equations in this vertical projectile motion. So we'll do more practice and more exercises on this, so that we get to understand this. We must enjoy this so that we can pass this concept. So guys, I will see you in the next one. So please subscribe, like the video, share it, and then write something in the comment section. Even if you don't know what to write, you can write 1 plus 1, then I will come to give you support and then say it's 2. So see you in the next one, guys. Bye bye.